IP addressing. Basic. Every computer requires a number for the purpose of identification. Here I am taking an example of two computers. The first computer would be called PC1 and the second computer would be called PC2. Every computer needs a number for identifying itself in the network. The first computer is assigned an IP address 192.168.1.1 and second computer is assigned IP address 192.168.1.2. How do you check whether these two computers are able to communicate with each other? We have a command called ping. Ping stands for Packet Internet Growth Protocol. It sends some signals to the destination computer which will help us find out whether there is connectivity between two of them. The destination PC would be 192.168.1.2. As soon as I hit enter here, what happens is a packet gets created on PC1. The packet would look somewhat like this. The packet would have something called the source IP address and the destination IP address. The source IP address would be the IP address from where the packet is originating from. The destination IP address will be the IP address where I want the packet to go to. When I say ping, when I use the word ping, which stands for Packet Internet Growth Protocol, Packet Internet Growth. It is a protocol that sends a packet called ICMP. ICMP stands for Internet Control Message Protocol. Internet Assigned Messaging Protocol helps us send packets to the destination PC with help of which I will get a reply, and the reply will help me to find out whether the destination PC is on or off. As soon as I send or rather ping on a destination PC, the destination data packet would be echo, ICMP echo. So what would happen here is this PC would send echo packets to the destination PC. When the destination PC receives the packet, it will send a reply to the source with the name of ICMP echo reply. So, when this PC sends an ICMP echo reply echo packet to PC2, when PC2 receives it, he will send a reply back. When the reply goes back, the source will become the destination and the destination will become the source. And the reply will go as ICMP echo reply. When the source PC gets a reply, it confirms that there is connectivity between these two computers. I'm just going to demonstrate this with an example. When demonstrating this, I will be using two computers. So we have got a program called Hyper-V, where I have installed two virtual machines. Details of Hyper-V will be in another recording. I am assigning an IP address on an XP machine. I will go to Start and press Run, or I will use the keywords Windows and the R alphabet on the keyboard, the Windows button and the R alphabet on the keyboard. And to get the network properties of a Microsoft operating system, I will use the command ncpa.cpl, which will take me to the network properties. I will double click on it. Go to the properties option. In TCP/IP properties, I will assign an IP address like the one I have configured in the painted screen behind. IP address 192.168.1.1 on the first PC. So this PC will be called PC1. Okay? Let me get this on the side. On the second PC, I will be assigning another IP address. Same here also. I will type in ncpa.cpl, which will take me to the network properties, and I will assign an IP address 192.168.1.2. So the first PC has an IP address 192.168.1.1. I type ipconfig, I get the IP address, and I go to the second PC. It gives me the IP address of the second PC after I hit the command. I'm checking to see whether these two computers are able to communicate with one another. I hit the command ping and the destination IP address. If that PC is connected to me and the IP address is configured in the right manner, I will get a reply. It's called as an echo reply. Okay? An echo reply. This PC has sent an ICMP echo packet for which it got an ICMP echo reply. Now, let's have a look at what happens inside the computer. When a packet goes from the source PC to the destination PC, it goes in a computer language. Let's convert that computer language into a human-readable language. For that, I have a software installed on the target PC called Wireshark. What will Wireshark do? Wireshark will determine all the packets coming in from this LAN card and convert it into a language that we human beings can understand. So opening Wireshark for the first time on this PC, and I'm going to click on Start. After clicking on Start, I will go to my source PC and I will hit the command ping and the destination IP address. Enter. Now, I will go back to the destination PC and stop the capture. Stop. It shows me some packets have come in. I'm sure everybody can see the source and the destination. The source says 192.168.1.1 and destination says 192.168.1.2. That is this PC. What is the packet that is sent? It is called echo request. And what is the packet that is sent back by this PC? Source, that is this PC 1.2, has sent to 192.168.1.1 Again an ICMP, but this time he sent an ICMP echo reply. So, just to repeat once again, this would be an echo request packet that is sent by the source to the destination. When the destination receives the packet, he acknowledges the source PC with an ICMP echo reply. So I'm sure all you guys have understood the first part, that is the basics. I repeat, I'm going to do the rescan again. Start new capture. Do I want to save it? No, I don't want to save it. Now, let's again do the same thing from the source PC to the destination PC. As soon as I hit enter, watch on the right hand side what happens. Yes, the right hand side PC says there's somebody sending some packet to me. Let me stop the capture. He says the source 1.1 has sent ICMP echo request packet to destination 1.2, who in turn replied with ICMP echo reply, and this way the source PC will make sure that the destination PC is up and running. Let's take another example. In this example, what I'm going to do is, I'm going to change the IP addressing. Let's change this IP address to 192.168.2.2. Remind you guys, I've changed this to 2.2. The earlier IP address is 192.168.1.1. But obviously, what's going to happen is, when the packet gets created, the destination IP address will be 2.2 now, right? Let's not talk about the reply right now. Now, what happens now? Will these two PCs communicate with one another? The answer is no. The answer is these two computers will not communicate with one another with this existing IP addresses. Why? Why is what we need to find out, okay? First of all, in order to understand whether these two computers will communicate with each other with these IP addresses that is configured, I need to take you to the IP address world. IANA stands for Internet Assigned Numbering Authority. It is a body who lays down guidelines about IP addressing, issuing of domain names, maintaining the registrars, domain name registrars, and also assign MAC addresses to various Layer 2 device manufacturers. Now, right now, we are talking about IANA, the IP addressing. So, we have two types of IP addresses today. One is the IP version 4 and IP version 6. Today, I will be talking about the basics of IP version 4. We need to understand that every IP address is made out of 4 octets. Every IP address is made out of 4 octets. So this would be octet 1, this would be octet 2, octet 3, and lastly octet 4. So there are 4 octets in an IP version 4 address. And just to repeat once again, this would be first octet, this would be the second octet, the third octet, and the last octet. Why is it referred to as an octet? It is referred to as an octet because each of these decimal numbers in the octet is made out of 8 bits. Each octet is made out of 8 bits. For example, the binary equivalent of decimal number 192 would be represented like this. These are altogether 8 bits. Computers understand binary language, not decimal numbers that we human beings understand. So when we type 192, what is happening internally is this binary value gets created so that a computer understands it. Now the question is, how does this binary work? And how did I get this number like this? So let me take you to the world of binary digits. 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. 8 bits. Every bit in this carries a value. For example, the last bit will have a value 128, then 64, 32, 8, 4, 2 and 1. If I had to ask you, what is the binary equivalent of decimal number 1? For example, I have a decimal number 1. How would you represent this number in binary? Answer would be as follows. This 0 carries a weight of 128. This 0 carries a weight of 64 all the way to this 0 carrying a weight of 1. Since this 0 already carries a weight of 1, what we could do is we could turn this bit on. 0 stands for off, 1 stands for on. And then I convert this 0 into 1 and I read the binary equivalent of 1 like this. 0, 0, 0, 0, 0, 0, 0, 1 is the binary equivalent of decimal number 1. That means we human beings will see 1, but computer understands this number. Of course, computer does not need to understand anything about the weightage for each of these binary bits. Computer just says, okay, this is the binary equivalent of decimal number 1. I write the number above so that we human beings can identify what the equivalent numbers are. If I have to ask you what is the binary equivalent of decimal number 2, the answer would be this 0 carries a weight of 2. So I will turn this bit on, representing that number 2 is highlighted, and read it like this. 0, 0, 0, 0, 0, 0, 1, 0 is the binary equivalent of decimal number 2. If I have to ask you what is the binary equivalent of decimal number 8, your answer would be this 0 carries a binary weight of 8. You would read it like this. 0, 0, 0, 0, 1, 0, 0, 0 is the binary equivalent of decimal number 8. going ahead, what would be the binary equivalent of 3? The binary equivalent of 3 would be 2 plus 1. You would read it like this. 0, 0, 0, 0, 0, 0, 1, 1 is the binary equivalent of decimal number 3. What would be the decimal number of the binary equivalent of decimal number 9? 8 plus 1 would give me the binary equivalent of decimal number 1, which would be 0, 0, 0, 0, 1, 0, 0, 1. What would be the binary equivalent of decimal number 192? Answer would be 128 plus 64. 1, 1, 0, 0, 0, 0, 0, 0 is the binary equivalent of decimal number 192. This was a bird's eye view on binary. I would be having another video talking about the details of binary addresses. My question still remains the same. Will these two computers communicate with each other? Meaning, I am sitting on PC1 and I try to ping this specific IP address. We need to still understand a bit more about IP addressing, after which you will be able to find out whether these two computers will be able to communicate with one another with the given IP address. We have various classes of IP address. The classes of IP addresses are class A, class B, class C, class D, and class E. Every IP address belongs to certain class. To find out whether a specific IP address belongs to a specific class, you need to understand that every class has a range assigned to it. For example, if this is an IP address, the first octet would be this. The second octet would be this. The third octet would be here, and this is the last octet. Class A says, if the first octet of an IP address is anyways between 1 and 126, that IP address is said to be a class A IP address. I repeat, if the first octet of this IP address would be anyways between 1 and 126, it would be defined as a class A IP address. This is not a class A IP address. Class B says, if the first octet of an IP address is anyways between 128 and 191, that IP address would be termed as a class B IP address. Class C says, any IP address whose first octet is anyways between 192 and 223. Class D says 224 to 239, and class E says 240 to 255. All these classes would refer to the first octet to find out which class this specific IP address belongs to. I'm sure You must have already guessed it out. This is a Class C IP address. Oh yeah. You must be wondering, what about the 127 IP address? The IP address 127 is reserved for loop-back testing. Now, what is the meaning of this loop-back testing is what will be covered during the course. We cannot use this IP address as a valid IP address in our computers. Meanwhile, which class does this belong to? Yes, obviously, as we already discussed, this belongs to a Class C address. That means the entire IP address would be said to be a Class C address. My question still remains the same. Will this computer communicate with this computer or not? Answer is negative. No. Why? No? No communication between these two computers. This is a cross cable, or we are using a switch in between, okay? Why will these two computers not communicate with one another? Answer is their network IDs do not match. What do you mean by network IDs? What do you mean by network IDs? Let's take a basic example of a human being whose name is Bob Charlo. And you have another user called Kevin Lobo. These are two human beings. By the last name itself, you can confirm that they are not real brothers. The last name of these two human beings are not the same, so they are not brothers. They will not be able to directly communicate with each other. Similarly, like what we have the last name for us human beings, a computer has something called network ID. Network ID is an equivalent to the last name of a person. What you see right now here is nothing but the IP address. You need to find out the network ID of this IP address. Both of these would have a network ID associated with it. If the network ID would match, they are brothers. They will ping. If the network IDs are not the same, they will not ping, no matter what, since they are directly connected to a cross cable. How do I find the network ID of an IP address? In order to find the network ID, you need to first find out the subnet mask of an IP address. Now, what is the subnet mask? And where do I get it from? The subnet mask is that number which helped us to derive a network ID of a specific IP address. I repeat, subnet mask is that number or element through which you can find out a network ID of a specific IP address. From where do I get the subnet mask? Now, in the IP version 4 world, again you have class full IP address and you also have the class less address. Right now I am referring to class full address. For class full address, we have the following subnet mask predefined. These two will not have any predetermined subnet mask. So class A would have 255000 as its subnet mask. We are referring to a class full address, not a classless address. Remember, guys. Class B would have a subnet mask like this, and class C would have a subnet mask like this. As soon as you find the subnet mask of an IP address, you will write down the subnet mask of these IP addresses. Any guess what is the subnet mask of this IP address? Yes, it belongs to a class C address. So definitely I place a class C subnet mask underneath this. So is with the second IP address. And I have a small and beautiful calculation to identify the network ID in case of a class full address. In order to find the network ID of an IP address, what I would do is, wherever I have a 0 in the subnet mask, I will copy that 0 into the network ID section. And wherever I have 255 in the subnet mask, I will copy the numbers from above into the network ID section. Only till 192.167.1.1. So this is the subnet mask. I'm sorry. This is the network ID of this IP address. And what about here? I will copy the 0 as it is. Yes. And copy the number from the above into the network ID section. So, this is the network ID of this IP address, and this is the network ID of this IP address. These two network IDs are not the same. Their network IDs are different. The network IDs of these two computers are different, and since they are directly connected through a cross cable, they will not be able to ping, they will not be able to connect with one another. Let's take another example. Let's take another example. PC1 is configured with an IP address like this, and PC2 is configured with an IP address like this. I repeat, this is the IP address. I need to find out the subnet mask of this IP address so that I can derive the network ID of the respective IP addresses. My question to you is, will these two computers communicate with one another? I repeat, I go to PC1 and type the command ping and the destination PC's IP address. My question to you is the same. Will these two computers communicate with one another when they are having a cross cable configured? Answer: yes, they will communicate. Those who are surprised, Let's jot down the subnet mask of the respective IP address. The subnet mask of the first IP address it belongs to a class B address. This also belongs to a class B address. But just by being a member of the same class will not help us find whether they will communicate with one another. So just like before, wherever you have a 0 in the subnet mask, I'll copy the 0 as it is into the subnet network ID section. Wherever I have 255, I will copy the number to that extent from the above IP address. I repeat, wherever you have a mask, you will copy the mask as it is. Wherever you have 255, you will copy the number from the above into the network ID sections. These two network IDs resemble one another. They are the same. They are brothers. They will ping. They will ping. They do match. There will be communication. Yes. There will be communication between these two computers. Did you understand? This will complete the first part of IP addressing. The second part of IP addressing will be in the following videos. Please watch. Thank you very much. Have a nice day.